All right, so so I was saying that you can plot your frequency, your cumulative frequency curve. You first would have to construct this table, which is your cumulative frequency distribution table. And then now, from here, you're going to plot your graph, and you will get a cumulative frequency polygon or cumulative frequency curve known as the ogive. Some persons may pronounce it ogive or ogive. It's the same actual thing that we're referring to. So our ogive or ogive, when we plot it, it will have a particular shaping more like a half of a bell or a S shape. If you don't get that shape, it means that something is wrong with your values. All right. So here you would put in your values in terms of your graph. So you have on your x-axis, you would start off. You notice that our cumulative frequency table start with 149.5. And if you notice on this axis, closer to the 0 position, we start our values from 149.5. Now this axis, it wouldn't necessary for us to start our value from 0, because our first boundary value is 149.5. So if we start from 0, what it means that this 149.5 would have ended up somewhere out here on the axis, and we really don't need that. So what we did was to put our first boundary values starting at the beginning of the axis here. So in other words, we kind of shrink up the x-axis and start from the 149.5. So if you notice here, we would have now plot our boundary values against our cumulative frequency values. So remember that we are plotting the boundary values with the frequency in the cumulative frequency table. And if you can recall what the table looks like, then our first boundary value would have a frequency of 0. So hence this first point will be exactly on the 0 frequency table. Mm-hmm. All right, now for our next cumulative frequency value, the boundary value that would be plotting against. So we have 154.5, which is our next boundary value. And our second cumulative frequency value would be 8. So we would plot that 8 on the y-axis with that's second, guys. So you plot the 8 on the y-axis with the 154.5 on your x-axis. So that would give you this point here. So this point would give you the point for the cumulative frequency 8 with 154.5. So you're plotting these values together. All right, so the next cumulative frequency value you would have 24. So we would plot 24. So 24 would be right here on your frequency axis. Let's say that would be 24. And then now you would plot it with the third boundary value, which is the 159.5. Let me see the hands up those who know how to plot these values. Okay. So on your x-axis, we have our boundary values. On our y-axis, we have the frequency. So whatever boundary value you have, you look for the corresponding frequency. So our next frequency value that correspond to 164 would be, was it, anybody remember what was the next frequency value? It would be what? 67. So we have 67 for the frequency. And we have 164.5 for the boundary. And the next one we would have what? 94. So we have 94 on your frequency axis. And you plot it with the boundary values, which is 169.5. And the last frequency value is 100. And that is plot against our last boundary value, which is 174.5. All right, so after we find our points, all we need to do next is to connect the dots. If you connect the dots, you should get a curve looking like this. All right, now, this is not so perfect, but your line should be connecting with all these dots. And then your curve would look something like this. Now, the name of this curve is what we call the O-give or the O-guide. Now, this curve is what we are now going to use to determine our median value. All right, so this curve is important because this is a curve that we're going to use to determine a number of the values, like our median values, our lower, we talk about our quartile, semi-interquartile values, and so on. We're going to use this curve to calculate those, all right? So our median value using the curve, what we do, we look for the mid value of the frequency. So for the frequency column, the mid value, you have from 0 up to 100. So the mid value from 0 to 100 would be 50. So you look for that mid value. Now, your mid value here should correspond to your median value, but your median value going to be on your x-axis. So the mid value on the frequency will correspond to the median. Now, our median value then going to end up somewhere here, which if we do a rough estimate, it would be about 162 maybe 162.5 or somewhere there, approximately. All right. So that's what your median value would be. Now, notice students, because sometimes students confuse the median value with the midway value on the frequency column. So the median value is not a frequency. The median value is one of the x values read from the x-axis. All right, so it is the value that you get when you find the mid value on your cumulative frequency and correspond it to the value on your x-axis. All right, so to do this by way of a graph all you're going to do, you take your ruler and draw a horizontal dotted line from the mid value on the cumulative frequency. So this mid value would be 50. Draw a dotted line, a ruler onto the curve. Then now you draw another dotted line coming down vertically. And wherever it cuts that axis, then you read off your median value. So the median value would be read from this axis. All right, everybody's clear with that? Let me see the hands of those who understand how to find the median value using this graph. All right, so I see persons are putting up their hands kind of reluctantly. What about those who are not seeing your hands? Mr. Geno, are you good? All right. All right, moving along then. So just to recap, if we are to find the median of a group distribution, we first need to construct a cumulative frequency curve, frequency curve. But before, what we need to do is to calculate our boundary values and our cumulative frequency values. And those values become the values that we're going to be plotted for our cumulative frequency curve. All right. So if you're given your table with your ordinary frequencies in terms of group distribution, you're going to be adding 2 extra columns to that. One column you calculate your boundary values. The other column you calculate your cumulative frequency values. Now your boundary values, you easily find your boundary values by adding the upper limit of one class, the lower limit of the next, and divided by 2. And make note, there is a shortcut way of doing that. And so if you add the upper limits and the lower limits of one class and divide by 2, you should get the same value. But generally, you look for the difference between those values. The difference is 1. You split the 1 into 2, which is 0.5. You add 0.5 to all of the values in the right column of your table. And so you get all the boundary values. Now, for your cumulative frequency values, those you use the subtotal calculation. So just like the cash register, you put in your first item, you get a total, and then now you add that item to the second, add the second item to that, and then you get a subtotal. Ms. Toller, have a question?
No, sir.
All right, can lower your hand for me. And so you keep adding each frequency value, and as you add them, you put down the subtotals. Now the subtotals will be the cumulative frequency values, and those are the values you're going to plot with your boundary values to get this curve. And when you plot, your curve should look like this, having this S-shape or bell shape, half bell looking curve. If your curve does not look like this, that would mean that something is wrong with your values. All right. Now, after you plot this curve, what you need to do next, in order to determine what the median is, you go to the cumulative frequency axis, which is the y-axis or the vertical axis. You find half of it, which is the mid value from, so you look from 0 to 100, find half of 100. So that will give you the mid value for your frequency. So it will be 50. From this 50, you draw a dotted line to meet your curve, which is the ogive. Then you draw a vertical dotted line to meet your x-axis, which is generally the boundary values. And then now you just read that value from your x-axis, and that value is what we use to be our median. All right, everybody's good at that. All right, so moving along. We may also calculate what we call our upper quartile and lower quartile values. Now, when you hear the word quartile, what really quartile refers to is really a quarter. So if the median is the middle value, then it would be, we find the median by cutting the frequency in the middle. So that would be the 50 mark of the frequency. So to find the quartile now, we cut the frequencies into quarter. So the first one, we cut it halfway here to get 50. It means now we're going to cut from 0 to 50 halfway again. So halfway from 0 to 50 will be 25. So here we have 25. Now, once we cut it at 25, just as before, we construct a dotted line to meet our ogive. And then now, wherever we meet the ogive, we're going to construct another vertical dotted line to meet your x-axis, which is the boundary axis. Right at that point where that vertical line meets the x-axis, we're going to call that value our lower quartile value. So the value here would be approximately, so this right at this point is 159.5. So this value, I would estimate it to be something like about, say, 160. Somewhere around there. Yeah. So this 160 here, this 160 value will be our lower quartile value. Now we generally call this Q1. All right, so Q1, which is our lower quartile value, would be approximately 160. Now, so you have Q1, then you have the median. We also refer to the median as Q2. So Q here refers to quartile value. So Q1 would be the quartile value 1, Q2, quartile value 2, which is the median. And then now we talk about Q3. And Q3 now, we divide the upper half of the 50 from 50 to 100. The upper half would fall on the frequency axis. It would fall at 75. Now we construct our dotted line to meet our ogive. Then we come down vertically from where it meets the ogive. And the value that we get at this point, we call this value Q3, which is quartile 3. Now this value, based on what we have here, would be approximately, so here is 164.5. So I'm estimating this to be let's say this would be about 165. So what we'd have here now, so we have 165 for Q3. So in terms of the quartile values, Q1 would be about 160. And Q2 would be the median, which is 162.5. And Q3 would be approximately 165. And those will give you your quartile values. Now, another name that we call the quartile, now we talk about quartile deviation. All right, and we're going to define that shortly after. All right, so our quartile values, we have our lower quartile, which is Q1, our second quartile, which is the median, and our upper quartile, which is Q3. So lower quartile, Q1, upper quartile, Q3. Now, to calculate our quartile deviation, we will need the lower quartile and the upper quartile. So for quartile deviation, we have a formula that we use to calculate the quartile deviation. All right, now quartile deviation, and I'm going to just put QD for quartile deviation. So our quartile deviation has the formula half Q3 minus Q1. All right, so that's how we calculate our quartile deviation. Now, what is a quartile deviation? Now, when we talk about deviation, we're referring to how much you move away from. When you deviate from something, that means you move away from something. So deviation here refers to how much you move away from the mean, or in this case, the median, right? So to determine how much you move away from the median, we use this formula to calculate the deviation, right? So it is half Q3 minus Q1 that give you your quartile deviation. And so if we are to use the values that we have estimated Q1 and Q3 to be, then this become half we said that Q3 is approximately 165, so it will be half 165 minus Q1, which is 160. So we'll subtract 160 from 165. And that would give us, in the bracket, 5. So we have half of 5. And half of 5 would be 2.5. So in terms of our quartile deviation, the value would be 2.5. And this value would tell you how far you move away from the mean in terms of on either side of your mean. So the deviation value would be 2.5. Let me see your hand if you understand how to calculate your quartile deviation value. All right. Very good. Now let me see the hands of those who are able now to go through, construct your cumulative frequency table, and then to construct the curve or the graph, and be able now to find your median, your Q1, your Q2, or your Q1 and Q2 and Q3, and to calculate your quartile deviation. Let me see the hands of those who feel like they will be able to do that. All right, good. All right, so moving along. So here we have Q1, which is quartile 1, Q2, which is also the median, and we have Q3. And then now we talk about quartile deviation. Another name for our quartile deviation is semi-interquartile range, right? So we can either say quartile deviation or we can say semi-interquartile range. And the formula as was given is half Q3, half bracket Q3 minus Q1. And you work that out. Now, sometimes from the same curve, you may be given a number of other questions to determine from the curve or from the graph. All right, so here are some questions that would reflect interpretation from the graph. So they're saying you are to now find by using the O-guide, by using the curve, the number of men with a height less than 157. Now remember that these heights are found on the x-axis. Remember, it's only the frequency that you get on the y-axis. The actual x values, which would be the same as the boundary values, you find those on your x-axis. So if it is asking you to find the number of men with height less than 157, what value are you supposed to be looking for here? So they give you the height. You want to find the number of men with a height less than 157. Can somebody tell me what would you be looking for on your curve? So if your heights are given on your x-axis, what is given on your y-axis?
Frequencies are on the y-axis.
All right. Now, remember when we started off, we said that the frequency determines what? What does it?
The amount of time something occurs.
Right. So, this case, the height would be telling the height of men, but the number of men would have to be based on the frequency, because the number of men would be how many men of 157, right? So what we're going to do, look at our graph now. We find the height of 157, and from that height we determine how many men, and the number of men must be determined by the cumulative frequency axis. All right, so here we have our O-guide again. And the first question we want to find the number of men with a height less than 157. So the heights are on the x-axis. So it means that on your x-axis, you need to find 157. So on your x-axis, your 157 would be somewhere approximately there. So what you would do, you would draw your dotted line up to meet your curve, which is the ogive. And then now you draw your horizontal line to meet your vertical axis. Now from your vertical axis, you're going to determine the number of men who have a height less than 157. Now, if from 157, our dotted line point to this value here, give me a rough estimate of what this number would be here. If you look,
15, sir.
yeah, so it's roughly 50, right? Now, would you say that the number of men with height less than 157, would you say that that would be 15?
No, sir, since we start at 157 points, so 157 would be included in that, I'm assuming.
How about the question is, do we include 157?
No, sir, it's a less than 157, so 157 would not be included.
Right, so it means that we would not include this height of 157 in our values. So when we get 15 here, this 15 is telling you that 15 men
It's 157.
have a height of 157. But we don't want how many men have a height of 157. We want how many men have a height less than 157. So the height is less than 157. A height less than 157. So for instance, 156. So 156 would be somewhere here. Right? So if you have 156 here, and then now we can use 156 now to give us a rough estimate on the graph. So if we have 156 here, it means if we follow the same pattern up with our dotted line and come across, then this value would fall somewhere below 15. So we can safely say you would have about, say, 14 men with a height less than 157. You get that, guys? Let me see the hands of those who understand what I'm saying. So if you're using a curve to determine a value which is less than a particular value, what you want to do is to first find that position on the frequency axis for that value which is less than. So here now, the value that we're looking for is 157. So you go on your x-axis, you find that x value, 157. You draw your dotted line to meet your ogive, then you come across to meet your frequency. Now the value that you read from the frequency would only give you the number of men with height of 157, but because the question asks for height less than 157, that means that you could not include this 15 that we would have estimated here, because this 15 tells you the number of men whose height would be 157, but we want the number of men whose height would be less than 157. So you think of a value which is less than 157. So you can think of 156. And if you construct a dotted line to meet up here and go across, you see that it would fall less than 15, which is approximately 14. All right, so the answer to that question would be the number of men with a height less than 157 would be approximately 14. All right, everybody follow that so far?
Yes, sir.
All right, so let us go back to our questions. So the next question asks, what is the number of men with height between 155 and 165? So we can find that on the graph. So the heights that we're working with here would be 155 and 165. So on our graph now, we would look for those heights, 155 and 165. So now we have, for the 155, we draw a dotted line up to meet the curve, and then we go across to meet our y-axis. From 165, now we draw our dotted line going up just the same, go across to meet your frequency axis, and then we write that value. Now, we see that the number of men who would have a height of 155 would be 9. We also saw where the number of men with a height of 165 would be 70. But the question is asking the number of men between the height of 155 and 165, right? So now when we think about the number of men between, it means that if the height of 155, we have 9, it means that all the men with heights less than 155, those would not fall between the height of 155 and 165. So from here going down, these values would be less than 155. From here going up, these values would be greater than 165. So what we really want is the number of men between these values. And to find the number of men between these values, then we find the number of men for the upper value, and then we find the number of men for the lower value. Then we are going to subtract the lower value, which is the 9, from the upper value, which is 70. So if you subtract 9 from 70, the number of men that you would have would be between here. And these are the number of men with heights between 155 and 165. So 70 minus 9, the number of men would be approximately 61.